We are going to talk about two different ways of building web applications, namely Spring Web, often called Spring MVC, and Spring WebFlux. These are two approaches offered by the Spring framework for developing web-based applications, each with its own philosophy. To use one approach or the other, you simply need to add the appropriate starter to your project dependencies, either SpringBoot Starter Web for traditional web development or SpringBoot Starter WebFlux if you want to build a reactive application. The first approach, Spring Web, uses a blocking thread model where each request is handled by a dedicated thread until the response is generated. This can become inefficient if threads remain inactive for long periods of time. For example, when threads are waiting for responses from database calls or calls to other microservices. We've prepared the diagram displayed on the screen to explain the concept of blocking threads and the potential impacts this could have on the APIs of our microservices. What you see on the screen is an application, an API, running on a Tomcat server, for example. In this Tomcat server, let's assume we only have 5 threads available to handle incoming requests. The requests are on the left side, and on the right, what we can observe are calls to external systems. That is to say, our API will call other microservices or databases. So now, if we assume that we have 5 threads available, and here we see that there are 6 calls happening at the same time at moment t, what will happen? The first 5 requests that reach the server will be handled by the 5 available threads. However, the 6th request will have to wait until a thread becomes available. And how will this simply play out? Well, this request will have to wait until the other requests have finished processing. This could take some time, or it could be quick. And let's imagine in this example, it will take 1 minute. If we imagine that each request takes 1 minute, that means the 6th request will have to wait at least 1 minute before it can be processed. Even though the threads are blocking, this technology meets application needs in most cases. An example use case could be setting up a web application to manage a library. On the screen, you can simply see a class, a controller in our API using this Spring Web approach. What you can notice is that in the method signatures, we often return objects. So beans, which will then be converted into JSON that is sent to the client side. And that's not the case with Spring WebFlux. And that's what we'll see next. Spring WebFlux is based on an asynchronous programming model and is non-blocking. It uses the reactive paradigm to handle requests. This allows server resources to be used more efficiently, especially for applications that perform a lot of input-output operations. This technology is suited for reactive applications that require asynchronous operations and a high level of scalability, such as reactive web services, real-time applications, and high-performance applications. You should know that the learning curve for Spring WebFlux is steep, especially for those who are not familiar with reactive programming. But it offers increased flexibility and performance for modern, high-load applications. For an architecture to truly benefit from the reactive paradigm, all layers of the application need to be reactive: the front end, the back end, and even the databases. For example, in the code on the screen, you can see how to retrieve a list of events as they become available, instead of waiting for all the events to be fetched from the database. You can also see that in the signature of our getAll method, we don't return a list of events, but rather a stream of events, unlike in Spring Web. In Spring Web, you would typically return a list of events instead of a stream of events. Of course, for the architecture to be ideal, the database in this example would also need to be reactive. In summary, the choice between Spring MVC and Spring WebFlux depends on your specific needs. Spring MVC is ideal for traditional web applications, where data access patterns may be blocking, whereas Spring WebFlux is suited for applications that require high concurrency and non-blocking operations, offering better resource utilization for intensive workloads. This could be the case in high-traffic applications that require high performance. And that's all for this session.